Hello and welcome in. My name is Mark, aka the Markster. This is video number 18 in the FreeCAD series. Today we'll be making this donut cutter. I recently updated FreeCAD. Now we're up to version 0.19, revision number 19694. And I'm using Windows 10. So this is a cookie cutter, a donut cutter, modeled after one that we have here at the house. The master chef decided that the one we have is too small, so I decided to make one a little bit bigger, so our bellies can get a little bit bigger. In the last video, I mentioned that we would perhaps be making a model in this next video here, which is this one, using a combination of the constructive solid geometry modeling and a sketch-based approach. So we'll do that with this model here. The round part, we'll make that with some cylinders. And the top part here, the handle, we'll make that with a couple sketches, one for the profile and one for the path, and we'll sweep that around. So let's go ahead and get started with this. I'm just going to hide this. It's a little bit of a complex model, so I might want to refer back to that from time to time. This is the spreadsheet that I'll be using. I don't think we need to create one from scratch since I already have this one. We have 6 parameters. We have the radius. This is the large round radius. This is actually the inside radius, 40 millimeters. And the wall thickness will determine the outside radius. So my walls will be 2.5 millimeters thick. The inner radius is the outside radius of the innermost cylinder, and that again will be the same wall thickness. The height is the height of that lower round part. The handle height is the height of the handle. I'll show you what I'm talking about here. This height from this point to this point, that's going to be the handle height, and handle width will be from this edge to this edge in this direction. We also have a couple holes in the top here, and that's so you don't have air. You have some air that can get in there, so when you cut your donut it won't get stuck in there or be as apt to get stuck. So the first thing we'll do is make this cut object from 2 cylinders as the large part for cutting the outside. So we'll need 2 cylinders for that, which we'll do here in the part workbench. Go ahead and create 2 cylinders. I'm going to label these outer and outermost is what I used the other time. So the outer cylinder will have a radius ss.ss, and that will be radius, and the outermost will be that plus the wall thickness. So radius plus the wall thickness. And now we need to set the height. We can select both objects at once and set the height for both. I believe this will work. Maybe not. It's not letting me do the... It's not letting me bring up the formula editor if I select both. See, the expression engine is not available, so we'll do them separately. I want this parametric, and this will be the height. And this will also be the height. Next thing we need to do is move this inner cylinder down in the Z direction by the amount of the wall thickness. I'm going to press the equals key, ss.ss, select wall thickness, and that needs to be a negative value, so I can put a minus sign in the front. Now we're ready to make a cut to produce this object. If I were not doing this as a demonstration, if I were just making this, I would probably just make this with a sketch and extrude it. But it would require a couple of more steps. Let's go ahead and make the boolean cut here. Now we have this cut part made again, which was this one. Now let's work on the inner portion. So we need 2 more cylinders. One we'll call inner, and the other innermost. Innermost is the part we're going to cut out of the inner. This is the one that we want to use the inner radius for. This is the inner radius. And this one will be a little bigger. That'll be inner radius plus wall thickness. The height will be the same as the others. SS_height. This one also needs the same value. Hope I'm not going too fast. Okay, now we need to cut cylinder out, but we need to cut it out of not only the inner, not only out of this cylinder, but we need to cut it also out of the top part here. So what I'm going to do is fuse now. Fuse the cut and inner one together first, and then cut this one out of that, so it'll cut them out of both. So now we have this part made, and we can proceed with the sketch-based approach. So we can go to the sketch workbench and create a new sketch. We'll put it on the XY plane. You can map to this face, but I prefer not to. There is a bug in FreeCAD called the topological naming issue that we want to try to avoid. So rather than mapping directly to a face, I will map the sketch just to the XY plane, and then move it up by the amount of this height property. So I make it on the XY plane. Then I can switch over here. Let's go ahead and close the newly made sketch and switch over here. Change its placement position. The Z, we'll press equal here, and we'll go height. F5 to recompute. Double click. And now our sketch is positioned where we want it. So I'm going to draw the handle here, and this will be using the slot tool. This tool here, it's just a convenience that we can use provided in the sketcher. That makes it a bit easier. It sets a few things up for us. It gives us these two lines. It gives us these two arcs. The arcs are made equal to one another, and they're connected with a tangent constraint. So it's just a convenience function. It's not any new elements. It's just using two arcs and two lines, and 3 or 4 constraints. So we had a variable that was the width of the handle. We can apply that. First, let's apply this radius here. I'm going to set this radius to the wall thickness times 2. I think that's what I used on the other one. Might have used wall thickness. I think it must have been wall thickness, not wall thickness times 2. So wall thickness only. This is live TV, folks. Okay. And now you can apply the width. This length here. And the width minus wall thickness times 2. So what that does, because this radius is the wall thickness, and because we want this handle width property to be the distance from the tip of this arc to this one, so this length needs to be 5 millimeters less than what we selected in the spreadsheet, which is 21, you see here. So that's the reason for that little formula. And now how far do we want this out? Let's apply symmetry first in this direction with this line here, with this horizontal axis line. So we can select these 2 points and the axis line and apply symmetry. Now we only have 1 degree of freedom remaining, and that's this position here. If I remember correctly, I used these points and I set this at the radius times 0.9. Let's see what that looks like. I believe that's the formula I used. Let's see if I can find which sketch that was. This one here. $36. Just to verify that it's the same. Yes, 36. So that's that sketch. That's the cross section of the handle. Gonna be pretty close to the edge. Now we need the path that's gonna create this path. The sketch to create this path to make the handle, so we can sweep the handle. Click into empty 3D space to clear no selections. Create a new sketch, this time XZ plane. You see that's the front view. Now this tool here, switch between section and full view. If your sketch is hidden by some object, this tool here will let you work on it. See what it does. Now I want to begin my arc even with this inside part, so I can make an external link, a link to external geometry to this vertex here where the arc and the line meet, and that's where our sketch will be starting. So this tool here, create an edge linked to an external geometry, will be a point on here. There it is. Right click to get out of that. So now we have a point that we can use as a starting location. You see, even though I link to this point and it's back here, further away from the sketch as we view from the top, the point is still here on the sketch. So I did not have to make a link to this line because it was right here on the edge. I'm not explaining myself well, but your links to external geometry are going to be on your sketch plane, lined up with the object you're linking to if it's not on the same plane. And this is exactly what we want in this situation. So now we draw our handle, and I'm going to use the multi-line tool, the polyline tool. This tool enables you to draw lines, and they're automatically connected one to the next, so you can just keep drawing them. If I use the line tool for this, let me right click and get out. If I use this tool, I would have to then go back and catch this point again, which is not a big deal, but it's more work. So this is a good convenience tool. And there are some other features too. You see where it says M cycles key behavior, M key cycles the behavior. You can draw arcs with the same tool by pressing the M key and switching between modes. But I want to show you this tool here. That's why I didn't do it like that. Create a fillet between two lines or at a coincident point. So we can enable this tool here. Select this point and click it. Select this point and click it. So you see it, right click to get out of there. You see it created an arc for us and connected it with the tangent constraints, the endpoint to endpoint tangent constraints, which is what we want. And I believe this arc is the one I used 2 times the wall thickness for. I'm going to set the equality constraint so that they're both the same size. I'll do it to these 2 lines as well, and they're going to both be equal. And I'll set this radius to the wall thickness times 2. Now this line can be anywhere. We have 2 degrees of freedom remaining, and you can see what they are. It's the position of this point and the height of this, which is our handle height. So we can set this to be the same distance from our vertical axis as this point by creating the symmetry constraint between these 2 points and the vertical axis. Here we use the symmetry constraint for that. So now we need to set our handle height, and for that we can go from this point to this point, use a vertical constraint, and we have the handle height parameter in the spreadsheet. So now the sketch is complete for our path. Let me turn off this mode. So you can see now we'll be able to sweep this profile along this path to create our handle. And to do that, we need to be in the part workbench. We select the sweep tool. What was the name of our path sketch? I forgot. Let's see. When I click here, when I get the right one, it's going to highlight. There it is. So sketch 3 is our profile. Create solid and print it. select our sweep path. Because it's comprised of multiple lines and arcs, we need to select all of them, holding down the Control key. We're done selecting our path, and OK, we'll do the sweep. We're nearly complete. We have 2 holes right here to do. You can see on the original. Let's hide these 2. You see these 2 holes? It looks like we're closer to the edge in this one than I was in that one for some reason. Open this sketch. See what the difference is. This one's 36. And this is 2.5. $36, 2.5. I don't know why that's further out. Times 0.9. Let's check this one. Times 0.9. I might have lost why this one's further out. Do I have the same radius for both? Yes. Sketches our position 0. I don't know what it is, but I don't like it being this far out. Let's try 0.8 on this. That's closer. There's something I'm doing wrong. I'm not sure what it is. Maybe I measured this height in a different location. We'll just roll with this. Now that's more like it. Still not exactly the same, and I don't know why. Okay, now let's make these 2 holes in here. And that can be done, obviously with cylinders we could do that. But let's just do it with the sketch. So we go to the sketcher, make sure nothing's selected. Create a sketch on the XY plane. Let's close it. And let's move it up to the height property. the height parameter. And now we're where it needs to be. Once again, we can use this tool. See, that tool hid the handle. Switches between section and full view. It hides objects that are interfering with your view of the sketch. So now we add a couple circles. Set them on this horizontal axis. You see the point on object constraint. Pick a point onto an object constraint. It's set automatically. If you miss it, no big deal. Let's say you were close but not quite there. Select the point, select the edge, in this case it's the horizontal axis, and apply it. We want these two to be the same distance from each other relative to the vertical axis. So we can apply this symmetry, or we can use the point-to-point symmetry as well. Either one would accomplish the same thing. Notice now one of the point on object constraints was removed because we have auto remove redundance enabled. This constraint was redundant now because the symmetry constraint ensures that it's going to be on the same horizontal position. It's going to be on the line because this one's on the line, and we have symmetry. So we have 3 degrees of freedom remaining. We have the radius for each circle, and where exactly are they going to be positioned along this line here. So let's make them both equal with the equality constraint, and we'll set the radius. In this case, I believe I used wall thickness divided by 2. Let's see what that looks like. Yeah, that looks about right. They're not big holes. It's just to let some air go through so your dough doesn't get stuck inside of it. Bigger might be a little better even than that. So the 1 degree of freedom is how far from the origin are we. We'll set a horizontal distance constraint, and let's try radius times 0.7. See what that looks like. That looks good to me. The reason to use the radius and a ratio of that radius is when we change the radius in the spreadsheet, it's all going to remain proportional. So now let's go back to part. We'll extrude that sketch. This is an advantage that part workbench extrude has over the part design pad operation, which is analogous to it. In part design, this will still work in this particular case, but if this were the first sketch that we were doing, you couldn't have 2 separate circles here because it has to be all one contiguous part. This would work in part design because of the earlier work that we did. It will all be one contiguous solid. But even if it were not, it would work in the part workbench. So we're going to extrude this symmetrically. It's not necessary to go symmetric, but it doesn't matter. We're going to let it stick out a little bit on both sides. Okay. And we want to relate this to the wall thickness in case we change the wall thickness later. It'll remain symmetric. So I'm just going to say wall thickness times 3 just to make sure we have plenty above and below. So we can make the cut. And we'll cut that from cut 4. And then we can fuse with the sweep. There's an extra edge here that's not needed. This is our final object. I have refine set to false. The default is to set it true, but I have it on false. I don't need it, and it's a little quicker without it. And there's this bug that occasionally appears. It's rare, but sometimes it'll fail. So you might not even notice that it failed. So I keep it false until I'm ready to use it. So that removed that extra extraneous edge. Now we can apply our fillets and chamfers. I applied a chamfer on this one. That might be a mistake. I'm going to print this. I'm going to print it in PLA. And it's going to take a long time because it's going to require a lot of support. I thought about printing it in 2 pieces with this part on the bottom. That would be a lot faster. And print the handles separately and glue them together, but I decided I didn't want to go through the trouble of gluing them together. If I was printing it in ABS, I can glue this with acetone, or it could be held together with little screws. Make some holes for some screws, but I think it'll be stronger printing it all at once with support, and then remove the support later. That's going to be my strategy. You might be able to hear the 3D printer in the background. That's what's making that noise. So let's apply some fillets. I definitely want to fillet these edges here for increased strength. Let's open the fillet tool. We'll select, what's the name of this shape? Fusion 3. The fillet tool. Fusion 3. There you are. We're in select edges mode. You do not have to press the control key to do the multi-selections here. Notice the fillet was applied in the sketch already. So if you have trouble applying a fillet after the fact, can't get it to work, you can make it part of your sketch and incorporate it into it like that. Sometimes anyway. Another option, if you just can't get it to work and you need it, a workaround would be to add a cylinder, small cylinder, appropriate size. We could fillet these edges too if you wanted. I'm not going to. I'm just going to leave it like that. Let's see what 1 millimeter looks like. I would like it a little bit bigger than that. So I'm going to double click here. And I'll choose, let's choose 2 millimeters. That looks good. I make chamfers here on the one that I'm printing, but I'm having regrets already because those walls are 2.5 millimeters thick, which should be good enough. But how reliable will that be with a chamfered edge? But we're going to apply the chamfer here. Fusion 3 is our selected shape. Choose select faces. It'll let me select this face. It won't. And why it's not letting me select that face? Not letting me select anything. Let's pre-select the face. Chamfer. Oh, I had the wrong thing. I had Fusion 3 instead of Fillet 1. Fillet 1 is the new object now, not Fusion 3. That was why it wouldn't let me select. So let's deselect and choose select faces. And by selecting the face, you get all the adjacent edges selected. So I thought a chamfer would give me a little sharper edge. I need to do that face too. But like I said, I'm having remorse already, so I don't know how well that's going to work. Set this to 0.5. So if you do make one of these, that'll be your decision. And now, that's going to close out this video for today. We showed that you can mix constructed solid geometry techniques with sketch-based modeling in the part workbench. If you use a spreadsheet and you adjust your sketches from the base plane, you can avoid something called the topological naming issue. I'll probably do a video next talking about that, showing some examples of where you can run into that issue, what it is, what it causes, how to fix it, how to avoid it. So that'll be a good subject for a video coming up. So as always, I thank you for watching and hope you have a great day.